Okay, uh, it's about 8 o'clock, 8:30, something like that. I'm Scotty Gex. I'm your grades 101 instructor. I'm back again. We've already talked about the syllabus, had a little video. So now we're going to get down to the heart of the matter and start diving into this grade setting adventure that we're going to have here. Now you're looking at week one, and we're basically, I think we went through this. I want you to read this, uh, go through this. We may have a big blue button. You probably will need one by the time you get down to uh, the middle of week two. It gets kind of rough and bumpy. So once we get to week one, don't forget your pre-test and your submission practice and the test on your uh, syllabus. Remember, go to the home page to click on the syllabus leads link if you want to refresh your memory. Now then, week two starts off. Its name is that I called it the basics. Let's see what's in this overview. Might give us a hint of what to look for. The Here's a guy from the Oklahoma City campus, actually, looking through a hand level. Upon completion of this module, the student will be able to define grade and elevation, demonstrate understanding of the engineer scale, in other words, how to read a grade rod, demonstrate understanding of basic stake marking, like basic cut and fill, and understanding of vertical and horizontal measurements. We'll deal with both of those. Vertical, of course, is up and down kinds of measurements, high and low, and horizontal is across the horizon uh, types of measurement. But we'll be able to deal with both of those. The newest thing that you will be encountering is vertical measurements, both high and low. So let's go over here and go this route, look at the modules and follow that. Say, I'm going to try to get through this a little quick, and but not too quick. So we saw the overview. The first thing we want to do is, I think this right here is the video that I'm making right now. So let's click on this thing. Yep, it's going to go right here. And again, we're going to have an introduction. There'll be a ton of grade terms. I'm not going to deal with those. That'll be up to you. You read them and don't put them to memory. Just know them and understand them. Then we'll talk about basic stake marking, and we'll cover the engineer's tape, and then we'll get into vertical measurement, and we'll see where we'll go from there. So again, I want to go back to the module thing right here and make sure I'm not skipping anything. Uh, Here's where all those terms are. I'm just going to give you a glimpse, and then I'm going to move on. As you can see, there are bunches of them. I'm going to say this crowfoot thing, this one, I don't know if you've ever heard of that far, if you come from industry, or if you used them in the certificate program. But a crowfoot is a reference point. It's uh, like you would put a hub. Some of you may know what hubs are. If you don't, you will by the time you leave this course. But a hub is a little 2-inch square stake that you would put in front of a lath, a grade stake, because that hub's not going to go anywhere. Now, if you use the ground for a reference point and it rains and you're in sand, it's liable to wash away 3/10 of that reference point, which would be dirt gone. But if you put a mark on your stake that looks just like this line is still going to be there, whether the dirt washed out from under it a little bit or not. I just talked about a hub. Grade is elevation to the top of a fill or the bottom of a cut. Offsets, we'll get into those later on. It's stakes that have information on, but they're out of harm's way. We put them off to the side. And as long as you know that horizontal offset, you can always find your stake or where it's supposed to be if you knock it over. Original ground percent profile, we'll talk about that. The grade boot is a fun thing that we're going to learn how to do, and the hike up has to do with where to put the grade boot. Grade boot is a known distance above desired grade. Uh, I think, yeah, desired cut. Now, we can use a boot in a fill situation, but primarily used in cuts. Uh, Fill boot is a little bit rare, but not unheard of. So I said I wouldn't stay here long, and I'm not. So once again, back to course modules. We have done the terms. Uh, what's in here? Introduction to grade setting. Uh, this is something that you can read. It has to do with safety. It has to do with talking about what grade is. These are all different elevations above sea level. We'll get into a little bit more of that. And this is reading material here. What is a grade checker? That's the guy that runs around. Those are getting scarcer and scarcer all the time as a result of automated grade control. But it's still useful to know how to use that hand level. You will be in situations where you're looking at something that the computer's telling you to do, and you will know just by looking at it that something's not right. So you can jump out and find you a control point and go from there with your hand level, and then get back on the dozer once verified and take off again. Tools, go through this, take a look. You don't see this anymore, but you do see hand levels. I still have one. We use them when I go, if I'm on a in-person training thing. I think everyone should own one of these at some point and know how to use it and use it accurately. Uh, as you can see, this is what you see when you're looking through there. If this is what your target is, you can see the bubble needs to be center on the middle of that target. So up or down makes this is showing you how to level it. I'll let you guys take that. And to move up and down the stake without losing level, the whole thing you need to slide up and down. I hold it kind of like you hold a pool cue. Right here is how you want to hold that thing, and don't grip it tightly. Don't squat behind that engineer's rule, but get off to the side, kneel down, and you can lean over and get down a lot lower without being in a strain. Okay, so we've gone through that. Uh, let's get back over here to the modules. Let's see what's next. Basic stake marking. Now this is where we're going to start. And so let's start. A grade checker. Now here it is. I'm going to read some and talk some and point some. The grade checker becomes your job to mark the correct information on any grade stake that you put in for grading operations, and the methods you use on a lathe are not complex, but you will need to commit the fundamentals to memory. It's also important that you make all stake markings legible so anyone can read the information easily. That means you have to learn to use felt tip marking pen, which is not hard. They used to use those old lumber crayons, but not so much anymore. It needs to be clear, precise markings every single time. And throughout the book, you'll find that the words stake and lath are used, and it's important that we know the difference, which is not really anything. A lath is thin, and like lath is thin, and a stake is more, maybe it's a 2 by 3/4 or something like that. But stake and lath are be used interchangeably for our purposes. So there's the description of it. Cut stakes, now here we go. We're getting into the meat and potatoes here. Cut stakes are designated by the letter C written on the stake. Imagine that. C. Cut what? 3 9/10. See that little line right there? You don't put a 3.9. Why not? Because it may be mistaken for 39. Cut 39 feet and instead of 3 9/10 and see if you still have a job. So mark it clearly. The 9's a little bit smaller than the 3, up a little higher with a line under it. You read that 3 and 9/10. Same thing over here. Cut 5 feet and 6/10. You see that? Cut 5 feet 6/10. Here's that crowfoot that we talked about earlier. It's marked on the stake, and it is in this case, how far is it above the proposed grade? Here's the proposed grade. Here's the cut. So tell me, how far is this distance where this arrow is? 5 and 6/10, because he's wanting you to cut 5 and 6/10 from the reference point down to the proposed grade. So this is where the dirt is going to be, right? Look over here. We're going to the same place. Uh, the 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 grade checker's going to the same place. So why is this cut 3 and 9/10? This is cut 5 and 6/10. Can you tell me? Probably you can, because we're closer to the proposed grade over here. Over here we're 5 and 6/10 above where we want to be. Over here we're 3 and 9/10. So how do we know that? By the way, we'll get to that. We will get to that. But some way we knew that at this point we were going to have to cut 3 and 9/10 to get to the same proposed grade as over here. Over here we're going to have to cut 5 and 6/10. We will get to that. So those are cut stakes. Fill stakes are designated by the letter F. Imagine that. And the numerals follow the letter F indicate how much we're going to fill in this case. So we were looking at cuts and everything was going down. Now everything is going up. This is where the dirt needs to be, where you see my arrow moving across here. It's the proposed grade. Everybody raise your hand that knows the difference between existing and proposed grade. Well, there may be one or two of you. I don't see your hand up, but I think in short time we will know the difference. I'm going to tell you right now, the proposed grade is where you want the grade to be. The existing grade is where the grade is now, naturally. So we're going to change this to the proposed grade using fill. We're going to bring dirt in and fill it up to right here. In this case, we're going to fill it 6 and 8/10. In this case, we're going to fill it 5 and 3/10. Why is this 5 and 3 and this 6 and 8? Well, the existing grade is lower over here. We got to fill further. The existing grade is higher over here. We don't have to fill as far. So an on grade stake would be something like this, right on grade, and this is what you might see. You might see a GR. You might see a blue ribbon tied right here. Blue stands for subgrade, finished subgrade. So you might see a blue ribbon tied on here so that dozer guy could go by, or gal could go by here and eyeball it and get close to it. So moving on. I'm not going to spend any time here. This is just going how to hold your crayon, how to drive your lath, and how to tie your ribbon. We can spend our time better. Let's look at what's next. The scale, the engineer scale. Now, I want to ask the same question again. Everybody raise your hand that knows how to read a grade rod or an engineer scale, as they're calling it here. It's an engineer's scale is based on feet and tenths of a foot. Excuse me, I'm going to have to. Okay, uh, got allergies going on down here in southeast Oklahoma constantly year round. Every single allergy there is represented in southeast Oklahoma, and I have most of them. Okay, uh, I'm gonna point some things out here. As I said before, the engineer scale is based on feet and tenths of a foot. Uh, this is let's look at the large view here first. You can kind of see my little finger pointing at, well, in this case, 4 feet. So in red, and this will be what you see on a grade rod too. When you get to a whole foot, well, it's 4 foot in this case, right? So uh, you've got point 0.8, and you're in the 4 foot range. You've got point 0.9, and you've got 5 feet right here. So look at this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 tenths between this point 0.9 and this 5 foot mark. Now the 4 foot mark is back in this neck of the woods. It's on back here. But you know you're at 4 feet because it's saying so in red. You don't know where 4 feet is exactly, but you would know that this is 4 foot and 8 tenths. You would know this is 4 foot and 9 tenths, right? So because it's marked, and you know that's 4 foot. And then these down here are in hundredths. This is tenths, and these little marks are hundredths down here. Here's 1/10, and here's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hundredths, right? So uh, that's a real quick lesson on the engineer scale, but let's try to go a little further with it, talk a little bit about conversion. This is a ruler tape measure, I think, pulled out. On one side is the engineer's tenths, uh, based on tenths, and on the other side is feet and inches. So their illustration, this probably maybe a little hard for you to see, is measuring out to, well, let's go up here. This is measuring out 0.46. There's 0.45. This is 0.46 right here, as you can see that. Now, here is telling us that this is 5.56 inches, or 5 and 9/16 feet. I want you to take 5.56 and divide it by 12. That's right, you got 0.46 when you round it off. So that's how you convert uh, inches to feet. You divide by 12. If you had, in this case, we had 5.56 inches. We divided that by 12, and it gave us 0.46 feet, almost a half a foot. So that's your conversion factor. Uh, I know I'm going a little fast. Here's a better, maybe a little bit better. No, here's your 1 foot mark. In reality, here's from here, there's your 9 tenths, and then next is a foot. And that's what you're not seeing here. And this is a video, by the way, but it's kind of loud and it's in your face. But I want you to go back and play this video, and it'll give you a broader view of the engineer scale overall. And then read through these conversions here. Here it is where it says divide 5.56 by 12, you get your 0.463. Uh, and then you've got 9 inches. 9 divided by 12, that's 0.75 feet. See, 9 inches is 3/4 of a foot. You can imagine that, I think. But this is the proof of it, or the calculations of it. 6 feet and 6 inches. So we take 6 inches is 6 over 12. That's 5.5 feet, and 6 inches is a half a foot. And so it's that. So that's our little instant look at the engineer scale. Now we got more fish to fry, so let's look at what's next. Vertical measurements. A lot of reading on here. Now I want you to take care of some of that for me. There are only two directions of measurement for a grade checker. That's across the ground, which is horizontal, and straight up and down, which is vertical measurement. And vertical measurements is the one discussed here. In order to transfer grade from an existing or a known elevation, where my little arrow's going nuts down here in the right hand corner, that's on grade. That's a known elevation. That, my friends, is grades. So in order to transfer grade from an existing known elevation to an unknown elevation, here, we don't know what the elevation is, but we got to put a lath here. So we're going to have to figure out what the heck the elevation is here, or where this would be if I moved it over here. Where would it be on this scale? That's a good thing to know, and we're going to find out how to do that. So known elevation, unknown elevation, that principle is illustrated in 19. So in figure 19, since the existing last is marked GR right here, at ground level right here, transfer that elevation by means of the hand level and measure the height above the ground on the engineer's rule. So let's move it over here and take note of the reading over here. And we'll make this simple. Let's say that the reading, now you're holding, you got to visualize this. This 6-foot rule is one of those folding rules, and it's graduated in tenths, feet and tenths of a foot, just like we looked at a while ago. It has an engineer scale on it. Now, I am taking a shot through my hand level, and I'm looking right dead on this crow's foot, and I'm going to look at what my reading is right here. If my reading says 2 feet, when I put that stake in the ground, what am I going to put on that stake? My reading says 2 feet on the engineer scale. This is on grade, and all I did was, if you could imagine this, was pull this crow's foot over here by shooting at it through the hand level and seeing where it lined up on the engineer's rule. So I said it was dead on 2 feet. So when I drop a stake in the ground and I put a crow's foot on that stake, I'm going to write F2.0 because I'm going to need to fill 2 feet. Is that right? To get to this line of sight? See, I'm 2 foot below, but I said I was 2 foot below this because it read 2 foot, and I'm shooting at that. So from here up is 2 feet. So this is the line of sight. If and I'm not, this is not the proposed grade. Don't get me wrong. This is just, I now have the elevation, the grade elevation over here, right? So I have this mark over here now. So now I can measure up to here, and again, that's 2 feet. So in this case, it would be, if I want to get to grade, I'll have to add 2 foot of dirt in here. You agree? If it said 2.3, I would have to put 2.3 feet of dirt in there, right? To get to grade. It doesn't say proposed grade here, but it is this grade. And that's what I'm wanting, is I want this to be level across here. So I transferred this grade through a line of sight over here to the engineer's rule. Thinking about it? Got it? You understand it? Let's pretend we got it. And we'll move on to what's next. Let me check where we are in the module structure. Are we through with vertical measurements? I'm going to go back and look. Am I going back? No, we got more. We got more to talk about here. So let's move along here. Oh, we're going to get some numbers. Of course, we got more to talk about. It's important that you find a comfortable angle to hold your head while shooting. And we looked at that kneeling down on one knee and then kind of bending over. And that's the best way to do it. It's important. Anyone doing it for the first time tries to hold their head up perfectly straight. Unfortunately, that isn't practical most of the time. You'll notice in different illustrations that you will frequently need to get down on one knee or maybe both knees in order to shoot grade. When you get my age, being a grade checker gets pretty hard because there's a lot of getting down and getting up. But you got to find an angle that's comfortable so you can get an accurate reading. Now let's just look at this. Where is, well, 2 and 8/10? I'm going to read this just because I want to. And I think we're reading this and talking about this, I think. We'll see. It says, now is the time to get in the habit of saying 2 and 8/10. I'm in the habit of saying 2.8. I need to be saying 2 and 8/10, or 1 and 7/10, not 1.7. Make it a routine. A lath installed at a new location could be marked with a crow's foot. See, we got her marked with a crow's foot right here. Here's the existing lath over here. We know something here, don't we? We know how far this is right now because it tells us so right here. Okay. Now, let's see, mark at existing level and mark cut 1.1. Or you might choose to make the crow foot 1/10 higher than the ground level and make it cut 1.2. Either way, you'll arrive at the same proposed grade. Figure 21 shows, what figure are we at? 20. I'm not going to leave this one yet until we explain this. Guys, kneel down. He's got a line of sight pointed to this crow's foot. And we know what this distance is right here because this tells us it's 2 and 8/10 below the crow's foot to the proposed grade, right? 2 and 8/10, and they have it measured out for you. Now, this is telling me that on his engineer's rule, he reads 1 and 7/10, right? So he's not there yet, is he? He has something yet to do. What does he need to do to get down to 2 and 8/10? Well, he needs to get some dirt out of the way, right? So he can drop this ground down. How much? 2.8 minus 1 and 7/10 equals 1 and 1/10. So what are we going to mark on this lath? Cut 1 and 1/10. Here's another. How much is it here? And how do we know? From this point to this point, it's 2 and 6/10. It says so. Some in the process, they have already got this calculated out, and they know that it takes a cut of 2 and 6/10 from this crow's foot to be on the proposed grade. So how are we going to set this lath based on this lath? Well, we're going to pull this crow's foot over here and read what it says. Well, right here is telling you what it's saying. It's saying 1 7/10. Okay, but we need it to be reading 2 6/10. Do we not? Or am I wrong? We need from this line of sight to be 2 6/10, 2 6/10 down. Am I correct? I think so. So if I'm reading 1 7/10, that means I'm 1 7/10 down, but I need to be 2 6/10. In other words, I need to, when I set this ruler down here, it needs to read what? It needs to read 2 6/10. That way, I'll know that I'm on my proposed grade because that's what it's telling me it is. And this is my reference. I moved my reference over here. Right now, I'm 1 7/10 below my reference, but I need to be 2 6/10. So I have to cut 2 6/10 minus 1 7/10 is 9/10. So I need on the last, what goes on there? Cut how much? 0 9/10. I hope you got that, because we're moving on to the next one. Repetition strengthens and confirms. Figure 22 shows how you would measure 3 2/10 above the ground. We have a field above the ground if the proposed grade is 1 3/10 above the nearby grade elevation. Right here tells me that from here, the proposed grade down to this crow's foot is how much? It's 1 5/10 from here to here. So let me pull this over here to my lath, or my engineer's rule. And what am I reading? 1 7/10, right? It says that, right? But so how far do I need to be to propose grade? I need to be 1 5/10 up from here, right? Plus I need to be 1 7/10 up for here. So I need to be 3 2/10 up from this right here. So what am I going to put on that fill to put me up to here? Right here is 1 5/10. Right here's 1 5/10. But I'm not there. I'm down here at 1 7/10. So how much dirt is going to get me to where I need to be, which is 3 2/10? Fill 3 2/10. And that will put me at proposed grades. That will be this 1 5/10 plus this 1 7/10. And that will get me to where I need to be. So a fill of 3 2/10 needs to go on that lat to be at proposed grade. What's next? This may end up being a little bit longer, but we need to get it done before we move into the week 3. We're talking inside the week 2 module right now. The grade boot and the high cup. Okay, I'm going to read a little bit. Many times it's necessary to employ the use of a high cup. Over here you see the high cup, and here you see what's called a grade boot. This line right here and this number tells me that this line is 2 feet above the desired grade. The rest of it's down in here somewhere. We don't know that yet. All we know that this line, because it's a designated grade boot, is 2 feet above the desired grade. Now, they're calling this right here a 2-foot high cup. Okay, that's okay if this is your desired grade right here. That's okay. But that's not what's happening here. Let's move on. But here's the problem. I need this mark right here, like we did above. I need it over here. You see it's shown over here. So how in the world, if I kneel down and I try to shoot like I did before, look, there's a hump in my way. Now I could get the dozer or the backhoe operator to come over here and knock that hump down so I could see this, but I don't have to. What I can do is measure up 2 feet, take a shot at this 2 foot line, and what am I going to read over here? Don't know. But what do I have to do? I have to know that I need to make a mark. And then because I went up 2 feet, I need to measure back down 2 feet. And there will be my grade. There will be, that line right there now is even with this crow's foot right here. Right? Do you understand that? So this up here is not, this is not the proposed grade. This is line of sight. But it's telling me that it's telling me by saying that I'm reading 3 3 7/10 here, and then I drop down 2. I have 1 7/10 left down here. Do you get that? 1 7/10 down here because I dropped down 2. This right here doesn't have a fill on it. It just has my 2 foot hike up there so I could see over that hump. So I measured up 2 foot. I brought that 2 foot over. I came down 2 foot, and these two crow's feet are dead even now. So what is the point? There's no point, right? If this is grade and I want this to be grade, I need to fill this area here 1 7/10. This doesn't make a whole lot of difference right here. It's just if I wanted to subtract, if I shot and read 3.7 and I wanted to subtract 2 feet, I would come up with what is 2 feet from 3.7? 1.7. I would come up with my needed fill anyway. But it's just best to take a shot at this line over here where you hiked it up, make a mark on the left, and measure down. Forget the math. Just measure down 2 feet. And wherever that is now above this grade is your fill. So what goes on this left is fill 1.7 feet. Goodness, I hope I've got that right. If somebody texts me if I don't, or you want to debate it, that's cool. But I think that's right. All I'm doing is I'm getting around. I can't. The problem is, only problem I have here is I can't see this known elevation from here with my hand level. So instead of knocking this out of the way, which would be time consuming, it may be a lengthy deal going long ways this way. So I just measured up 2 feet. I offset it vertically. I gave it a hike up. And I took a shot at that, and I brought that 2 foot hike up over here. And then I took my 2 foot away, and it left me 1.7 fill. I could just take a tape measure and measure from here up to get to that grade, because what I want this right straight across here is my desired grade, because this is grade and this is grade. What's next? More. Yes, more. Now what do we got going on? For goodness sakes, this looks like a mess. Now then, a little bit more about the grade boot. I like what he has to say here. Looking at this situation, to keep me from having to squat down and to avoid dealing with this issue at all, I am going to pick a 4-foot grade boot to put on this stake. That way, I can probably stand up. I may have to just bend down a little bit, lean over a little bit, but I'm probably guessing that a 4-foot boot, which will be 4 feet, eventually is going to be 4 feet above the known or proposed grade, not known grade, but proposed grade. And we know where that is already because we don't need this to mark this stake. We don't need to know that cut if the guy marked this boot right. So let's check him out. If I want to put a mark on this lath that is 4 foot above this elevation, which is under the ground, but do I know how far it is under the ground? Yes, I do. It's 2 4/10 under the ground. So if I want this to be 4 feet above the proposed grade and 2.4 feet is underground, I take my desired boot and subtract the cut to arrive at a figure that'll tell me where to put this mark right here so it will be 4 foot above my desired grade. So 4 foot minus 2.4 feet is what? 4 minus 2.4 equals 1.6. 1 6/10. I'm having a hard time doing what I'm telling you to do. 1 6/10. So I measure up from here where the crow's foot is 1 6/10. I make that line, and that's going to make this line 4 feet above this proposed grade. Let me say that again. Looking at this stake, we don't need to know the cut, but we just happen to know it. They marked it here. But I'm standing over here and I don't want to squat down. I don't want to come over here and shovel this out of the way. So I'm just going to say I'm going to put a 4-foot boot on this stake so I don't have to squat down. So to know where the definition of a boot is a known point above proposed grade or finished grade, whatever you want to call it. A known elevation above finished grade. So I arbitrarily picked a 4-foot boot. I could have put a 3-foot boot, but that would put me down here basically another foot, and I'd be back in that situation. So this will give me clearance. And the problem is if there's no mark on this stake and I want this line to be 4 foot above this proposed grade, how do I do that? I take the boot that I want, whether it be 4, 5, 3, whatever, and I subtract the cut from it, in this case 2 4/10 from 4, and that leaves me 1 6/10 of a high cut. So I measure up 1 6/10, draw the line, put a 4 foot on, put 4 on it, and voila. So just look at add this up. If we don't believe me, let's take the 2.4 plus the 1.6. What is 2.4 plus 1.6? Plus 2.4 equals, guess what? 4. That proves that I'm in the right place. 2.4 plus 1.6 equals 4. So I don't know this in the beginning. To find this out, I just take the amount under the ground and subtract it from the boot, my desired boot, and that tells me where to put that line for the 4-foot boot. That's all there is to it. Uh, and next we have, oops, we have nothing. Is that what we're down to? All this thing. So this is like a little playground for what you can do with a hand level. Uh, Elevation, sometimes EL, sometimes ELV, is defined as the height above the level of the sea. Mean sea level is normally given the elevation of 0 and is generally the reference point for elevations throughout the world. Mean sea level is attained by averaging the average tide gauge readings of the sea over a long period of time. The standard for the United States was determined by correlating observed mean sea level elevations at Galveston, Texas, with that at a number of with that and a number of other stations. Everything is based on sea level. Now, in New Orleans, there are plenty of places that are below sea level. They have dikes there and things, and of course, cemeteries are everybody's buried on top of the ground because uh, New Orleans, I think, is for the most part below sea level. So, figure 25. Let's take a look at that. Let's just look at it. Let's just play with it. No, let's don't. Let's start at where they say starting elevation 300. Where's 300? Ta-da, right here. That's 1. Now, where do I want to go from here? I want to know where this 4-foot elevation is. How do I figure that out? Well, I can take this elevation of 300 right here, right, and I can start taking off. I know that this is 2.4 feet because it tells me this right now, but from here I can figure that hike up and add that 1.6. What is 300? This is 300 feet. What is 301.6? Uh, right there is 301.6 at where that 4-foot boot is. Because here's 300, the hike up, we know what that is. If we don't, we can figure it out by looking at that and this and see that it's 300.1.6, it's 301.6. Now, let's get over here, get the hand leveled out. Take a shot at this line right here, which we know is 301.6. It reads 4 feet right here. So what is 301 minus 4 feet? Just give me a second here. Uh, 297.6, 301.6 minus 4, 297.6. It's just showing you that you can do a lot of things with this. 297.6 is our proposed grade. What is this grade right here? Well, here's taking a shot here from here and reading 3.5 again. I know this is 301.6, so 301.6 minus 3.5 probably is 398.1. You can do that with your calculator. So I'm not going to spend very much time on this. It's fun for you to come over here and pick out points to do 1, find 3, 5, what's this? How can you use this to get this elevation? Can you? You know, this elevation. You know, uh, what do you know this 3.5? Uh, Probably because that's what you're reading across here. Uh, 4 foot is here. Why is that 4 foot there? Well, you got 297. If you want to know, I'll bet you end up at 301.6 if you add 4 to this. We know that's 4 feet because we shot it over here at a 4-foot boot, right? So the hand level uh, after the end of World War II, we had a lot of soldiers coming back from overseas. So the operating engineers got together and came up with this hand level deal because all these guys needed jobs and they just So I don't know how it all took place, but they got together and they said, we can do this and not have to call a surveyor out. We can let these guys run around with this hand level, teach them all these things, and let them set these stakes instead of calling the surveyor out. And ever since then, cost you $200 to $500 just for a surveyor to come out and resurvey one stake. And when you know how to use that hand level and you know these principles, you don't need that surveyor. I'm going a little bit fast, I feel it. Uh, the grade boot and hike up. I haven't watched this video. Uh, I'm going to let you watch that video. Uh, I think I wasn't expecting this video. I'm going to shut mine down and I'm going to look at this video and see if we need something different. So I'm going to stop my video at the grade boot and the hike up. And my video, I'll have to figure out where it started, but I'm going to stop it right now.